Good morning, everyone. Good morning. Hope all is well. Hope everyone is doing all right. Let's see if everyone's in. All right, looks like it. So, hope you had a great weekend. Hope we got a great weekend. Ready to get this one started. Good morning. Good morning. So, I believe we are at chapter six today. Closed out chapter five. Good morning, sir. Good morning. Last class. No, did we do the last class or we had a review day? Something like that. Either way, we're getting into chapter six today. Um, we do not have, if I'm not mistaken, we got this week, next week, and spring break is the week after next. I have it written somewhere. I believe I'm right. I know I wrote it down somewhere. Spring break is games on the 6th or the 7th. So we have this week and then next week and then spring break. So we'll look at knocking out chapter 6, and then that week going into spring break. It'll just be like a review week. I mean, I'm not doing a midterm. I didn't set up for a midterm for this semester. So what I'll do is leave that as an opportunity for you guys to ask whatever questions you want to ask going into spring break. Hopefully you guys can use, this time and that time to get caught up for those who need it. All right, good job, good. Use that time to get caught up and then come out of spring break ready to rock and get into chapter 7 and close out the semester. All right. So 6.1, discrete random variables. Random variable is a numerical measure of the outcome of a probability experiment. So its value is determined by chance. All right, I know I left this up for a while, so everybody done with the title. All right, your discrete random variables or your random variables are typically denoted using capital letters. All right, hold on a random variable. All right, so discrete random variable has either a finite or countable number of values, can be plotted on a number line with space in between each point. Of course, we're going to give you examples of what we mean by that in a second. Then we have a continuous random variable, has infinitely many values, can be plotted on a number line using an uninterrupted, can be plotted on a number line in an uninterrupted fashion. All right, let me make sure we're okay with continuous before I scroll up. So the next exercise is just, examples of something being discrete versus something being continuous. So we'll talk about the example and why is one discrete and the other one continuous. I'll give you a chance to write it down before I scroll up. All right, done with continuous. All right, so going back to the difference between the two, discrete has a finite or countable number of values. Continuous has infinitely many values. So let's look at the first two. We have discrete or continuous. I already have the answer down there, so we can just talk about why it is discrete versus why it is continuous. So we have the first one, the number of A's earned in a section of statistics with 15 students enrolled. So if it's countable, if you can put a solid number on it, then it's considered discrete. So if you're talking about the number of A's earned in the classroom, either 5 people earned A or not, or there were 7 people who earned A, or there were 10 people that earned A. If you can count it, then it's considered discrete. If you can count it and there's no fluctuation, there are no other options, then it's considered discrete. So what I mean by that is when you look at B, the weight of the sandwich at the deli, for the most part, if you have to weigh it, measure it, or something along those lines, is going to be considered continuous because multiple answers will work, depending on the accuracy of your scale. Um, in other words, if I were to weigh something that was 1.1, but if my scale is more accurate, then I weigh it at 1.12, or you have another scale that's even more accurate, 1.123. Um, those are all the right answer. It's just that one goes to the tens place, one goes to the hundreds place, one goes to the thousand place. So if it's going to be weighed or measured or something along those lines, for the most part, that will always be continuous. If you can just count it and there's no fluctuation, like if you count the number of people, if you count the number of cars, there's no such thing as 0.5 of a car or 0.2 of a car. So if you can count it and there's no fluctuation, there's no decimal range or anything like that, then it's considered discrete. All right. So when you look at C, the number of cars that pass through a McDonald's drive-through in the next hour, that would be considered discrete. Once again, you're going to count the number of cars. There's no fluctuation in that number. It's either 4 cars or 5 cars, maybe 10 cars, but there's no such thing as 10.1 of a car, 10.12, or anything like that. So that means it's going to be discrete. Everybody done with A? And then the last one, the speed of a car that passes the state trooper. Once again, that's something that has to be measured um, by, speedometer or his gun. So if anything's going to be measured, it's considered continuous because there are different answers for that. All right, any questions? Any questions? Let's go up. All right, probability distribution of a discrete random variable X provides the possible values of the random variable and their corresponding probabilities. So rules for a discrete probability distribution. And we talked about these rules already when we're talking about probabilities in general. All of your probabilities have to add up to equal 1. That's what this symbolism. So this symbolism means right here for number 1. All of it add up to give you 1. And then each one of those probabilities are in between 1, 0 and 1 inclusive. So once again, we talked about these rules before. It's just re-emphasizing that here for discrete probability distribution. All right, everybody done with the rules? All right, so which of the following is a discrete probability distribution? So we have these 3 options here. Have our variable going 1 through 5, and then the probability of each one of those variables taking place in each case. All right, and we talked about it, everybody good? So which of the following is a discrete probability distribution? So looking at A, that last value fails rule 2. Remember, rule 2 is that each one of our probabilities has to be in between 0 and 1. And so since that's negative 0.07, that fails rule 2. So it's not a discrete probability distribution. B, that fails rule 1 if you were to add them together. It gives you 1.18. Remember, they need to add together to give you +1. So nothing more, nothing less. All right, any problems with A or B? Okay, and then looking at C, add them together, they give you 1. I said something. Right, yep, if one of those rules fails, then it's not a probability distribution. So if you look at each one of those probabilities, they're in between 0 and 1. And then when you add them together, they give you 1. So C does represent a discrete probability distribution because it satisfies both rules. When you add them together, it has to equal 1. If it doesn't, then that's not, it goes against the rule. Not a problem, not a problem. Can I scroll up? If I done with the purple? All right. So I forgot whether MATLAB actually have a problem that asks for the mean of the discrete random variable or the standard deviation of the discrete random variable. If it does, the book really doesn't focus on it, but if it does, you can just use a website Apple calculator to find it. It's not really something that the book really focuses on, but I think I remember seeing like one talk about it, but just like any other time, all you do is Google that, mean of discrete random variable, type in the information and get your answer. But it's not really a focus. I think that's 6-1, yeah. So any questions on 6-1? Questions about 6-1? Everybody good, everybody straight? Scroll up. All right, 6.2, the binomial probability distribution. Binomial probability distribution is a discrete probability distribution that describes the probabilities for experiments in which there are 2 mutually exclusive outcomes. These 2 outcomes are generally referred to as success and failure. So an example of that in basketball, success is making a shot, failure is missing a shot. So two mutually exclusive outcomes. You can't miss and make a shot at the same time. So they're mutually exclusive. Mhm. Right. Experiments in which only two outcomes are possible are referred to as binomial experiments, provided certain criteria are met. All right, can we scroll up? So looking into that criteria, so it says referred to as a binomial experiment as long as certain criteria are met. So we get into that now. It says an experiment is said to be a binomial experiment if first, when the experiment is performed a fixed number of times, each repetition of the experiment is called a trial. Second one, the trials are independent. That means that the probability of one occurring is not affected by the fact that another one has occurred. So in other words, their occurrence doesn't affect the probability. For each trial, there are two mutually exclusive outcomes, success or failure. So don't forget, mutually exclusive means that you can't be both at the same time. Probability of success is the same for each trial of the experiment. Anybody holding on to number 3? All right, so the notation used in the binomial experiment, binomial probability distribution, excuse me. N is the number of trials of the experiment, lowercase n. So it says in the chat. Oh, somebody said it's still number 3. All right, sounds good. Thank you much. How about number 4? Anybody holding on number 4? You good? Let's go all the way up. Okay. All right, so notation used in binomial probability distribution. Lowercase n is the number of trials of the experiment. P is that probability of success. So that means 1 minus P will be the probability of failure. And then X is the number of successes in N trials. So you see right here, X will always be between 0 and N inclusive. So we'll put numbers on this. Hopefully it'll make more sense. But that's the notation. All right, scrolling up. Somebody holding on to the green. All right. So next exercise, determine which of the following probability experiments qualifies a binomial experiment. For those that are binomial experiments, identify the number of trials, probability of success, probability of failure, and the possible values of X. So I'll give you a chance to write that down. All right. So once again, we want to determine which of the following probability experiments qualify as binomial experiments. For those that are binomial experiments, identify the number of trials, probability of success, probability of failure, and possible values of X. All right, so we have an experiment in which a basketball player who historically makes 80% of his free throws is asked to shoot 3 free throws, and the number of free throws made is recorded. So in order for it to be a binomial probability experiment or binomial experiment, remember it has to fit these 4 criteria right here. So we're going to walk through those 4 in a second. Just give you a chance to copy it all down. All right, so the first one, is there a fixed number of trials? The answer is yes, there are 3. Talking about shooting 3 free throws. All right, are the trials independent? The answer is yes. Historically, this person is an 80% free throw shooter. That doesn't change just because you miss one or make one. So the probability of the next shot doesn't change. Are the events mutually exclusive? The answer is yes. You can't miss and make a shot at the same time. They have nothing in common as far as missing and making a shot. Your success and failure. And then is the probability of success the same for each shot? The answer is yes, because he's historically 80% free throw shooter. I can do that one. All right, so it is a binomial experiment because it meets all 4 criteria. All right, any questions before we go into the next part of this? Remember, if it's a binomial experiment, then we have to go through, establishing the number of trials and all the stuff like that. So, all right. So let's go through the notation. So N is going to be 3. That's the number of shots, number of trials. It's an 80% free throw shooter. So convert that to a decimal is 0.8. That's the probability of success making a shot. 1 minus P, 1 minus that 0.8 is 0.2. So that's probability of failure or probability of missing a shot. And then X is always going to be 0 to N. So 0 to 3 would be your X. And 0 means he would miss all shots. 1 would be he makes 1 shot. 2 makes 2 shots. 3, he made all his shots. Questions? Any questions? All right, can we scroll up? Not yet. We haven't gotten to the calculation part. This is just setting you up, making sure you're okay with the setup. So a probability experiment in which 3 cards are drawn from a deck without replacement and the number of aces is recorded. So remember the assignment or the exercise here is to establish whether we even have a probability experiment, a binomial probability experiment. Remember, we have to just check to see if it meets the 4 criteria. Then if it does, then we will go ahead and go through our notation. So the first one, is it performed a fixed number of times? The answer is yes, we're picking 3 cards. Okay. Then number 2, are the trials independent? The answer is no. So the key here is the fact that it says you pick it from the deck of cards without replacement. Without replacement means that you're not putting the card back. So now once you pick out of that 52 card deck, now you have 51 cards. So now you're changing the probability. You pick out a second time, you have 50 cards. Pick out a third time, you have 49 cards. So you have actually changed the probability. You change your sample space. So the trials are not independent. Picking one card does affect the probability of picking the next card. Now, if it said with replacement, then we would be okay to continue on. That means you would be replacing the card. So this one is not a binomial experiment because it does not meet all of the criteria. And that's where this exercise will end for B. All right, are we good to the next one? By holding on to the purple. So according to a recent Harris poll, 28% of Americans state that chocolate is their favorite flavor of ice cream. Suppose a simple random sample of size 10 is obtained and the number of Americans who choose chocolate as their favorite flavor is recorded. All right, scroll up. So now we have to check the criteria. Are the experiments performed at a fixed number of times? The answer is yes, we're obtaining a sample of 10. So we're picking 10 people. Are the trials independent? The answer is yes. Picking someone randomly has nothing to do with the chances you'll pick someone else. Are they mutually exclusive? The answer is yes. So if chocolate is your favorite, then that means there's no such thing as another favorite. Favorite means that that's the one that you choose to be your best flavor. So we're not talking about which one you like a lot. Do you like a lot of them a lot? We're talking about your favorite. So your favorite flavor is your favorite flavor or is not your favorite flavor. So they're mutually exclusive. Yeah, picking your best. Yeah, what you consider to be the best. And then the probability for success is the same for each. The answer is yes. Probability, they say we have 28%. So, all right. All right, any questions on those? The answer is yes for each. So that means we can go to the next step of just establishing what our variables are, notation. And so this experiment is a binomial probability experiment because it meets each of the criteria. All right, and scroll up. All right, so since it meets all of the criteria, we can go and establish the number of trials and all the good stuff like that. So N is 10, number of trials, that's the number of people we were choosing for our sample size. Probability of getting a person that chooses chocolate as their favorite was 28%. Probability of getting someone else is 1 minus that 28%, which would be 0.72, 72%. And then X is going to be 0 to N. So that's 0 to 10. 0 means that out of the 10 people you chose, none of them chose chocolate as their favorite. And then 10, all the people you chose chocolate as their favorite. Any questions? Any questions? Can you scroll up? Mhm. So when your classmates have mentioned calculation, this is where we get into that. If you have a binomial experiment, we can do our binomial probability distribution function. Right, done with that purple. All right. So if we want to know the probability of X is going to be the number of successes. You know, we talked about that's the last category right here. If you want to know the probability of getting one person that chose chocolate, you know, so that's what we're talking about X. So N is the number of trials like we talked about before, and P is the probability of success. So notice the formula right here. C is the only thing that we have not talked about. C is the combination function. It actually represents a formula. So you're not plugging in the value for C. You're only plugging in the value for N, X, and P. That's why C is not mentioned down here. C is a function in your calculator for combination. So once again, you know, you have the option of calculating this out, or you can Google binomial probability distribution calculator. And there are things that calculate it for you. All you need to know is what is X, N, and P. plug it in, and you can get your value. But this is something you could put in your calculator as well. Excuse me. X and n minus x are exponents. So you'll see when we plug it into the formula how that works in a second. Just give me a chance to write that down. All right, so let's look at the next problem. According to the CTIA, 41% of all US households are wireless only households. That means no landlines. In a random sample of 20 households, what is the probability that exactly 5 are wireless only? All right, so we write down our given pieces of information. Just like before, you establish what is your probability of success. It says 41%, so it's 0.41. Failure is going to be 1 minus that 0.41, which is 0.59. Number of trials, we have a sample of 20 households, and that means X is going to be 0 through 20. It cannot go past 20. And the lowest value would be 0. All right. So we want to know what's the probability of exactly 5 are wireless only. So this is plugging in the values into that formula. It's 20C5. Once again, combination is a function in your scientific calculator. If you need to know how to use your calculator, make sure you get with me, off class. Your calculator is not somebody else's calculator, so I wouldn't take up class time to discuss your individual calculator. So there'll be something that you will get with me either in office hours or, we set up a separate session so we can sit back and talk about the functions of your calculator. 0.41 is our P, and you're raising it to the 5th power. Calculators have this symbol to raise a number to a power to an exponent. Then 20 minus 5, 15 is what you're raising to that failure. This is for your exponent. Now, once again, if you're not using your calculator, if you Google, like I said, probability distribution calculator, you can skip all this and just type in the values that they ask of you, and then it will give you the answer. All right. Questions on what we have. So it gives you 0.0656 or 6.56%. Math lab will let you know how many decimal places they want of you. All right. So we talked about this before. Math Lab gives you one of these statements when they say in 100 trials of the study, we expect about 7, or we would expect about 7 trials to result in 5 households that are wireless only. So in other words, you take that number that they give right here, multiply it to that number that you calculated, and if you get 7 or about 7, then that's the right one. So if they did 1,000, then it would have been what, 65, about 66, So you take that number and multiply it to the number that you got in decimal, and it should match up here. And that would be your correct statement. Any questions before we go to the next one? Yes. All right, let's go to the next one. Fewer than 3 are wireless only. All right, so we're talking about fewer than 3, talking about 0, 1, or 2. So now we're looking at the probability of getting 0 people that has chocolate as their favorite, the probability of getting 1 as their favorite, or the probability of getting 2 as their favorite. So those are 3 different calculations that we will add together. And once again, as a matter of fact, I'll show you one of the websites that work where they actually calculate this for you. But if we were doing it by calculator, our personal calculator, we would do each one of them individually and add them together. All right, so everybody copy. So once again, how many decimal places you go out will be dependent upon what Math Lab is asking of you. So that first one, 0.000026. 1 would be 0.000363. And then the probability of getting 2 is 0.002397. Add those together, that's 0.0028. All right, question on that before I show you how one of these websites work for us. All right, can I switch screens? Everybody good? Everybody good? All right, so show you this real quick. So I will go in and do binomial distribution calculator, probability, let's see, distribution calculator, yep, binomial distribution calculator. Stat Trek normally works for me. Once again, you don't have to use it, it's up to you, whatever you want to use. There's some other ones down here as well. So it's going to ask you for those three things that I mentioned. Probability of success in a single trial for us is 0.41. Number of trials is 20. Then the number of successes. Now, if we go back to what we were looking for less than 3 or fewer than 3. So if you go back to it, let's put 3 in here and hit calculate. So notice right here, this is the one that says less than, you know, and it gives us a whole bunch of options. If you're just looking for equal to, that's there. Let me see something. All right. But less than 3, less than or equal to 3, greater than 3, and then greater than or equal to 3. All right, so we were looking for less than 3. That's right there, 0.0028 or 2786, but you know, they're rounded to 0028 for us. And if we go back to what we ended up calculating, oh no. And you see we have 0.0028. So Stat Trek is one that you can use. All right. Questions on that before we go to C? All right. So at least 3 are wireless only. So we say at least 3. So that means you're counting 3 and you're talking about everything greater than it. So at least 3 are wireless only. So now if we're going to do at least 3 greater than or equal to 3, we're talking about 3 all the way up to 20. So now with the app that, or the website that I just showed you, that actually calculated for you. But okay, yeah, not a problem at all. Not a problem. Take care. Thank you for letting me know. Be safe. So since we already calculated less than 3, we can use the complement rule here, and we don't have to go back to the actual website. If we don't want to, we can just use the 0.0028. Remember, the complement is everything other than what you've already calculated as your probability. So if we look at the probability of less than 3, the probability of greater than or equal to 3 would be everything else. So we'll take that 0.0028 and subtract it from 1. That'll give us 0.9972, excuse me. But once again, that website, if you would have put 3 in there, they gave you greater than or equal to 3. So you should have saw 9972 in there as an option for your symbolism. That symbolism right there. All right, any questions on that? Or look at the last one. All right, so last one, the number of households that are wireless only is between 5 and 7 inclusive. So now this one, you'll have to do each one of them individually. There are plenty of things you can go out there to find. Maybe they'll allow you to do 5, 6, and 7, together like that. But that one that I just showed you doesn't. So you would have to do these individually through the website. Type in 5, get that value. Type in 6, get that value. Type in 7. If you want to use your calculator, that's how you would do it in the calculator. All right. Put them in the formula, get your values and add them together. So we got 0.3381 once we do all that. Questions, questions, questions. All right, are we good? Everybody straight? All right, so this test 3, 5-1 through 5-4, 6-1 through 6-2. So now, there will not be a midterm, but we do have to talk about this test 3. And so is everybody done copying before I go to another page? All right, so I do have to proctor you guys at some point on some things, part of policy and everything like that. So what I'm going to do is create this test 3 option. So next Wednesday, which should be the Wednesday before we go into the spring break. So that's 3-3, nope, 3-2. We're going to do this test proctored. All right. So now here are your options for doing so, for taking this test. And this would be during All right. So, like I said before, I have to at some point proctor some tests. The first two tests we haven't proctored, but we do have to get some proctor tests in. So when I say proctor, you're not coming into class, you're not going to do anything that's going to be different than what we normally do. It's just that you'll come to Zoom like you normally would do. You will show your ID to the class, to the window, I mean not window, to the camera. You have to enable your camera and have it enabled throughout the process. And you would try to, make your attempt at the test. Now, um, that would just be a regular test time. You don't have to do it. Now, if you decide to take the test on your own time through Math Lab, then the highest score you can get on that test is an 85. Now, the reason why that is not a problem is because an 85 does not stop you from getting an A out of the course. So, but I do have to create this type of buffer type situation where it seems as if, there is a legit penalty for not doing the test proctored. But the 85 will not, well, give me your chance to finish explaining. So the 85 will not stop you from making an A out of the class if you choose not to take it during class time on the second. So test three, we're talking about test three, which is on chapters 5 and chapter 6. Once again, I have to proctor something at some point during this class time. Other than that, I'm not. You don't come to class, face to face. Most of you don't have your cameras enabled, so really, you can have your cousin from down the street taking the test or doing all of your homework for you. So we have to have some type of situation wherein I see you doing work that it has been, one of a part of the class process, just like we would in regular class time. So proctored means that I'm sitting here watching you take a test or doing something or doing an assignment. So once again, I'm making test three the original option for taking test three proctored. So that means on Wednesday, May 3rd, not May 3rd, March 3rd, you will come in prepared to take the test. If you choose not to, then it's fine. It's just that you would do it like you would any other time, but the highest score for that test taking will be at 85. All right. So questions on what I said up to this point? If so, unmute, and just go ahead and so everybody's clear. Everybody's clear. So, the next class and then the class afterwards. So we talking about Wednesday and next Monday will just be review days. You guys ask whatever questions you want to ask. You already have the test review posted, so you can go into the test review, see what things you may have trouble with, and what you want to ask me. Well, if you score higher than 85 here, it's not a big deal. You get what you get. If you score higher than 85 here, the highest you will get is 85. So, hopefully that answers your question. Let's see. Yep. So technically, you actually have 3 shots at getting, the best grade possible on this test. I mean, if for this test, here would be the proctored time when you would take it during class time. And it is just during that class time block. Now, if you need accommodations set, then you need to make sure you get with me, because if you're taking it on 3-2, the only time that I have is during class time, because then I got to go to my next class. So if you need to have accommodation that you have to have, like whether it be extra time or something like that, you need to shoot me that email if you want to take advantage of this option. If you don't, then if you're just doing it like that, it's just taking the test the way you would regularly. Excuse me, I had to sneeze. So if you're just doing it the second option, you just take the advantage of it regularly. There's no time on that or anything like that. Excuse me. Questions on this, and I'll shoot you guys an email with the details in it as well. Questions? Everybody good? Everybody straight? So once again, the next 2 class periods will be review days. And then that third class period will be a proctored test. Once again, it's not a midterm, it's just on chapters 5 and 6. So if you know you're not ready for it, then you really don't have to show up this day. Or if you just don't want to take it during the proctored time, you wouldn't show up that day. this test, you wouldn't see this test option till after this test time, so it'll pop up automatically after we take that test. All right. Questions, concerns, comments. You don't have to let me know. You showing up or not showing up will be you letting me know if you're going to take the test. I'm going to show up that day regardless. If you're going to take it, you just show up that day. All right. Everybody good? Everybody straight? Once again, like I said, I'll email you details. The same things that I said to you, but I want to give you a chance to actually ask questions if you had them.
I have found some questions, but I can speak in the end of the class.
Okay. Okay. Not a problem. Now you talking about questions on problems or questions about this?
Just for the class. No,
Okay.
about the test.
Okay. Okay. Not a problem. Not a problem. All right. So if you guys are good, I'm good. I get ready to go ahead and head to this next class. I'll see you on next class, and we'll talk more. Like I said, next couple of days are review, so it's up to you to take advantage of that as well, and go from there. All right, you guys have a good one. Take care. Yes, Ms. Parko.
Yeah, good morning.
Good morning.
I know that you didn't notice, but I missed like 2 weeks of classes.
Okay.
And because I have right now,
Okay.
I
Hold on.
have
Let me stop this recording for you because it's still recording. I don't want to, you about to say something.